Hello everyone, thank you for joining us for our second talk of the day. Our next talk is from Marko Krstic on Casper. In today's age, the internet has developed exponentially fast and only in a short amount of time. So fast, in fact, that some people who lived most of their lives without the internet have children who've never known a world without it. Hence the need for Casper. In his talk, Marko will cover this amazing solution, which has a goal of identifying and applying AI to protect young people on the internet. Marko, you're free to take it away from here and start your talk.
Thank you, Milan. Well, my name is Marko Krstic. I will talk about children agents for secure and privacy-enhanced reaction. This is our project funded under grant agreement number 825618 of European Union Horizon 2020 Research and Innovation Program. It is good to get back to data science conferences. I was here at the second, and now for the sixth that has European character, and it's great to get back. Firstly, I will say a little bit about me. I'm Marko Krstic. I have PhD in recommender systems, get by School of Electrical Engineering, University of Belgrade. Currently, I'm working as cybersecurity advisor at Serbia National Computer Emergency Response Team. So I try to combine academic research and everyday job to combine machine learning and cybersecurity. I will say firstly a few words about Next Generation Internet Initiative, which we are a part. Next Generation Internet Initiative is a European initiative for human internet that respect the fundamental values of privacy, participation, and diversity. The Next Generation Internet offers new functionality to support people's needs to address global sustainability challenges. The NGI is dedicated to foster a vibrant, open internet movement that links the research, policy, and society for the benefit of the society. We are part of NGI Trust, the next generation internet that deals with trust and privacy. The objectives on NGI Trust is to reinforce structure and develop the community of researchers, innovators, and technology developers to build the state of art in privacy and trust enhancing technologies, improve user trust and acceptance of emerging technologies, and to foster the exploitation and commercialization of results of selected third-party projects. One of such project is the Casper project, which get the funding for commercialization after the first funding for the research. How we in Casper team see the future of the internet? The future of the internet should be also the future of our children. We can communicate with our children. We can understand together different things. We could play together. We can do a lot of things together. But the future must be defended now, since there are many risks for the children. And we are trying to address some of them. For example, inappropriate content like porn, nudes, hentai, different challenges, etc. Cyberbullying, treats, blackmailing, insulting, sexual talks, etc. It is because our social interaction due to COVID-19, especially, it's more focused on the internet. So children are spending more times on the internet, and the games and the interaction that we have in our childhood is now on the internet. So we must protect the children there. If you go one step further, there are online predators that are trying to trick the child and get know the children and sexually exploit them. But furthermore, we also have indoctrination problems. So, especially with migrant crisis, migrations in Europe and in the world globally. So that is the reason why we are creating Casper project to protect the children on the internet in these situations which their parents didn't notice because they can't monitor the child all the time, and to protect the children from the threats that parents are not aware. Not every parent lived in internet time and not familiar of all threats on the internet, but also to respect the privacy of children and the whole family. Why is Casper project so unique? Casper is designed to work at human-computer interaction level. Uh, how you can protect now the children from the internet? You can protect. You can block. Use some according to DNS addresses, IP addresses that are famous for malicious activity. You can block their access to that addresses on TCP IP level. You can use some applications that for YouTube exist application that can block some of these threats, but how to protect from unknown future applications, how to protect the children from different cultures that don't use the mainstream's websites and social applications. So our conclusion was that this is only possible at human-computer interaction level. In order to protect the privacy, we are trying to implement the Casper locally on the children user device. So all data is kept on and don't go to cloud on the internet. How we imagine this detection process? Well, as I mentioned, we are considering human computer interactions and processing different content, audio, image, and videos, keyboard and keyboard text. Audio inputs go to the speech recognition and speech to text goes to speech to text conversions, and then we are using text processing text classifier to detect inappropriate content. Image and video, we are doing screenshots and then go to the image processing image classifier and using artificial intelligence to detect different inappropriate content and attacks. Also, we are using for now it is planned, but we found too obtrusive to use input from webcam, and we are using we are doing screen segmentation to do the text on the screen and doing OCR to convert to text and then process again through the text classifiers. During this project, we developed a so-called human computer interaction tracker that records all of these inputs, screenshots, and audio locally, and it is in proprietary software developed by Casper team. The screen segmentation, we are using we have different approach to the recognition of image content and textual content. For image and video content, we developed our screen segmentation database, annotated what is the picture on the screen, what is background, what is the text, and then use tiny overview on nuance algorithm and transfer learning methodology and modify to detect only image class. But on the other side, because we don't have so big database with textual content on different scenes, we use the Keras OCR that is available on GitHub. This approach is designed to detect text in the wild. Currently, for English language we are used, it combines character recognition awareness for text detection and convolutional recurrent neural network for text recognitions. Both are trained tightly, so it provides better performance than separate detection and recognition of the text. For audio speech to text, we found that Caldi software, Aspire chain model trained on visual English that is augmented with impulse responses and noises to create multi condition training, works well for now for our application. Caldi is selected among other softwares because provide us a lot of modularity to change the components like feature extraction, acoustic modeling, language modeling. Furthermore, we find the best parameters to achieve the Casper time synchronization and marking. The challenge is that we have on recording audio from the device is that some audio cards does not allow us to separate output in the input audio. But even with these restrictions, the system works well. For image, when we separate the image or video, we consider image video as the same for our system. We are using mobile net convolutional neural network for classification. For training such neural network, we get the NPID pornography database that is only for research purposes. Also, we find useful not safe for work version to GitHub link here, and also we created our own database. We have a cooperation with the school in Portugal, with NGO in Portugal that deals with youngs, and they design us and preparing for us scenarios, different scenarios. You can see the Casper system it's very good in recognition of inappropriate content. I would mention while we're working on our database and during the second part of the project, it is because that different cultures and it is not unique for all cultures, for all parents, what is appropriate for their children, what is not appropriate. So this is one of the problem, even if we achieve the 99.7% of accuracy for these classifiers, the problem is to define what we should block and how. On this picture you can also see that our screen segmentation or detection of pictures on screen works very well. For the text classification part, we considered 4 different data sets. Wikipedia that incorporate discussion comments from English Wikipedia talk pages that is manually annotated by 10 persons. From Spring, one 12,000 pairs of question answers which are manually annotated by three person. Twitter data set, 16,000 tweets are collected manually annotated. The tweets are collected by search of terms which are referred to religious, sexual, gender, and ethnic minorities. And lastly, we have Ask FM question and answer part published on the user profile with bigger data. The problem with this, it's too wide, and we must choose for the first implementation what we will deal, and we choose to deal with blackmailing, sexual abuse, and insults. For that purpose, we are using text classification. We are using bidirectional long short-term memory networks. Through experimentation, we discovered that bidirectional networks are much better because of behavior of cyberbullies, sexual predators that can write something on the beginning that is important for the last sentence. We must process text a little bit to get out generic words that are found on our PC commands on Viber and other messengers. So this is the how it looks text classification results. Our with red, it is marked the text that is inappropriate in communication with children. I miss here the picture that our text screen segmentation that should find the text also find these other boxes as text. Our further but as I must mention that some of these, especially audio processing and also text processing, is it can function in real time on devices like mobile phones with low restricted limited resources. So our second project, second part of Casper project, deals with optimizations of these results as well as internationalization. So we are collecting data for Serbia, Macedonia, and Portugal because the partners of these projects are from these countries, but we also have plans to get support for much more languages. What we consider for performance optimization, we are considering using efficient net developed by Google through neural architecture search to be optimized for mobile phones. Also, we are considering using efficient DET for screen segmentation that increase performance, and we are expecting that could be computationally enough intensive to can be run also on a mobile phone. For this screen segmentation, we have a lot of expectation for ThunderNet. ThunderNet can achieve object detection and recognition even for Snapdragon and other Snapdragon processor that is most used on mobile phone, and I think 26 frames per second can process. For text detection and recognition, we also find useful Oct Shuffle MLT, that is end-to-end multilingual text detection and recognition. It reduces 70% flops for operating um, uh, for float operation per seconds. It uses so-called shuffle nets, and it can be appropriate to run even on mobile phones. For the part of the detection that can be incorporated on a local device, we are examining edge computing paradigm. This part is also financed by the second part of the project. So we have two ideas. The one is for home usage, that we have some kind of home device that will process audio or the parts that can be incorporated in software on edge on a user device. And the second one is to develop such a device for the school. So we will have the agent on the phone that will communicate with this device. Also, we are examining the efficient inference algorithms, like how to improve efficiency of our and of our algorithms on mobile phones. We are examining pruning, pruning the weights of neural networks, pruning the nodes of neural networks, also quantization, how it will influence the accuracy of results. So we see that this part can be also very important in further development of our project. As I already mentioned, we cooperate a lot with important with institutions and stakeholders that are important for our project. One of participant in our project is NGO O Mundo da Carolina, that deals with younger persons in Portugal. Also, because we must decide how long we will save the snapshots, the data needed for Casper inference. Is it needed to save it longer because of digital forensics? Can our system help and improve digital forensic readiness? So we are cooperating, and we are part of cost project, digital forensics evidence analysis via intelligent systems and practices. Also, as I mentioned on the beginning, we are trying to incorporate as much as social phenomena. So we are and address the current migration in the Europe and the world. So we cooperate with cost action, transnational cooperation on brewing migration and integration at school levels. That have a lot of psychologists, sociologists. So we are trying to define the best how to define with them how we can improve our system. The Casper team, I would like to say a little bit of our team. The project leader is Alexander Yevremovich. He's a guest lecturer at Harvard University and full professor at Singidunum University. My colleague for generation, Milan Čabarkapa, assistant at the School of Electrical Engineering. My other colleague from the industry, Georgia Hirsch, lead data scientist at Telenor Serbia. Our partners from Portugal, Nuno Garcia, Vice Dean at Faculty of Engineering, Universidade de Beira Interior. PhD Nuno Pombo, Mundo de Carolina, Portugal. And our partners from Macedonia, Ivan Čorber, Dean and Faculty of Computer Science and Engineering, University of Skopje. Ivica Dimitrovsky, Associate Professor at Faculty of Computer Science Engineering, is also at University of Skopje. Actually, they have a large conference on machine learning in academic conference in Skopje 2 years ago. Also Mladen Vejnović, Dean at the Faculty of Informatics and Computer Science, University of Singidunum, Serbia. He was one of the first who deals in the beginning of his career about audio processing. PhD Miloš Stojmenović, full professor at Faculty of Informatics and Computer Science, University of Singidunum. He is a specialist in computer science.